Hello, good morning, good evening. Welcome back to my channel, JBTeguihanon, Engineering and Chemistry tutorial. Let's continue on our study on the refrigeration system, but we are here now. Our topic for today is about sensible heat. Okay, we have done with the heat mode of transfer, conduction, convection, and radiation. And now we are going to go to, we're going to study sensible heat. Or there are two types of heat, right? One is sensible. It is something that you can feel, something that you can, you can feel that it is there, it is more, it is less, it is medium. So we call it sensible heat. So sensible heat level or heat intensity can readily be measured when it changes the temperature of a substance. Remember, for example, changing 1 pound of water from 68 to 69 degrees Fahrenheit. This change in heat level can be measured with a thermometer. The change of temperature can be registered. We know that the level of heat or intensity has changed. So that is called sensible heat. Okay. So what he's referring to is this one. The example that he had given, this one. From 68, right? When he defines British thermal unit, that the British thermal unit is, or one British thermal unit is equal to the amount of heat that changes the temperature of 1 pound of water from 68 degree Fahrenheit to 69 degree Fahrenheit. So in other words, one British thermal unit is a heat needed to raise 1 degree Fahrenheit of 1 pound of water. Okay? So this is actually the sensible heat. Okay? That is actually a sensible heat. In itself, it is the definition of sensible heat. Okay, sensible heat can be applied also in air conditioning. When we study psychrometric chart, we have also sensible heat there and latent heat. So we have actually the total heat in the psychrometric chart. But we will not touch that because we are in the refrigeration system as of the moment. So keep it in your mind. We have sensible heat, that is the heat that is capable of changing the temperature of a substance or of a water from 1 degree or lower degree to a higher degree of a temperature. Okay? And then latent heat, or we call it latent heat. This is actually a hidden heat, hidden, okay, heat. This is the heat is added in this process, but no temperature rise occur. You cannot notice it. There is no change of temperature that take place. For example, is heat added to water while it is boiling, okay, in an open container. Once water is brought to the boiling point, adding more heat only makes it boil faster. It does not raise the heat temperature. See figure 1.13. Yeah, this one. Okay, figure 1.13. This is an example of latent heat or hidden heat. Okay, but it is famous to be called latent heat or latent heat, right? So in figure 1.13, adding three times, okay, three times, one, two, three. Here is only one. As much as heat only causes the water to boil faster. Here you see it boils normal. When you add three flames, okay, it is just an example by figure. It's boil fast. The water boil fast. Okay, the temperature is the same, but you have added this heat here to flame, or you have added heat, but it doesn't change the temperature. It's still the same, 212, but water boils fast, right? Okay, so now we go to the figure here, and this is actually figure of 1.14, and the heat slash temperature. So this is heat in BTU. So we know what is BTU, right? Definition of BTU. 1 BTU is a heat added to raise 1 degree Fahrenheit of 1 pound of water. That is 1 BTU. Here we have 0 BTU, 100 BTU, 200, so on and so forth. Okay, to 1400. Here we have the degree Celsius and degree Fahrenheit. So this is basically your temperature. Okay, and the heat temperature graph, this is a graph. 1 pound of water at atmospheric pressure explains how water responds to heat. Okay, what he's saying, an increase in sensible heat causes to raise its temperature. An increase in latent heat causes the change of state. Change of state. Okay, for example, from solid ice to a liquid water. So we can see the difference then, right? So when you add latent or sensible heat, temperature rises means the temperature changes from low to high. So it raises the temperature of the water. But if you add heat, latent heat. Okay, the temperature remains the same, but the phase of the water changes. For example, from ice to a liquid, or from a liquid to a vapor or gaseous. Okay, from here, point one, we have your point one. So, water is a form of ice in here. You can see it here. Form of ice at point one, where example starts. Okay, point one is not absolute zero, it is 0 degree Fahrenheit, and is used as a starting point where no heat has been added to the ice at point one. So we can see the heat content scale at the point is zero. So at this point it is zero. It starts from here, right? So it starts from there. And then uh, at point two, at point two, or two, heat added from point one to point two as is sensible heat. So what happened? Temperature rises from 0 degree Fahrenheit to 32 degree Fahrenheit at your point two. So what happened? Okay, it adds small or some amount of water here, this portion, right? Okay, so temperature rises. What is that type of heat? That is sensible heat. Okay, because the temperature of water changes. Now from 2 to 3, obviously, he adds what? He adds he adds he adds uh, latent heat from 2 to 3. This is latent heat. So there is no change of temperature, but there is a change of what? There's a change of what? Of phase, right? Okay. At point 2, it reaches the ice. It is melting at a temperature of 32 degree Fahrenheit. This means that if more heat is added, it will be a latent heat. It will start to melt the ice, but not raise the temperature. So adding 144 BTU will change 1 pound of ice to 1 pound of water. Removing any heat will cool the ice below 32 degree Fahrenheit. So it added 144 BTU, and the ice become water. 1 pound of ice changes to 1 pound of water. So from here we go, from 3 to 4, you add, what did you add? You add here this, okay? You add this. Okay, you add this. Yeah, this one. Now then, this much of heat. And that heat is a combination of it slightly move this way from here up to this. Okay, and obviously it raises the temperature from 32 to somewhere 220 this much. Okay, and what happened there? So when point 3 is reached, I'm reading this. When point 3 is reached, the substance is now 100% water. Adding more heat causes to raise the temperature. Of course, this is sensible heat. Removal of any heat at point 3 results some of water change back to ice. This describes the removing of latent heat because there is no change of temperature. Okay? So heat is added from point 2, sorry, from point 3 to point 4. Sensible heat it is. So when it reaches point 4, 180 BTU of heat will have been added from point 3. So the water has heated from 32 to 212, which is at 180 degree Fahrenheit rise. Referring back to the definition of BTU, you will see that 1 BTU of heat energy raises the temperature of 1 pound of water 1 degree Fahrenheit. So 180 degree Fahrenheit temperature will raise 180 BTU of energy. This is what happened. Okay? 180 BTU. This portion here. This is what he's saying. Sensible. Okay. So from point 4 to point 5, from this point to this point, it's too much, right? We have the red one here. Okay. So you added latent heat. No change of temperature is the same, 212 or 100 degrees Celsius. Okay. You added 900 BTU latent heat. So what happened? We will read it so that we can see. So from point 4, represent 100% saturated liquid point. I'm reading this. The water is saturated with heat to the point that addition of any more heat will cause the water to boil and start changing to a vapor or steam. If any heat is removed, the water at this point will simply cool to a temperature that is lower than 212. Adding 970 BTU makes 1 pound of liquid boil to point 0.5 and become vapor. Okay? So that is a short story of what? That's a short story of our sensible heat and latent heat. okay, using diagram, okay, which is of temperature and heat. Okay, thanks for watching. Please subscribe to my channel, JBTeguihanon Engineering and Chemistry Tutorial. Bye for now. Thanks. God bless.